The Hubble Space Telescope (HST) has made significant strides in space exploration since its launch on April 24, 1990, aboard the Space Shuttle Discovery. It has become an essential tool for astronomers, revolutionizing our understanding of the universe. Hubble's ability to capture stunningly detailed images has opened new windows into cosmic phenomena. However, its journey was not without challenges. Shortly after deployment, NASA discovered a serious flaw in the primary mirror that resulted in blurry images, casting doubt on the mission's success. Despite this setback, Hubble continued to operate, capturing valuable images of planets and distant galaxies. A major breakthrough occurred in December 1993, when a team of astronauts embarked on a high-stakes servicing mission to correct the mirror's flaw. This mission was a resounding success, significantly enhancing image quality. Since then, Hubble has transformed our understanding of the cosmos, revealing majestic wonders previously hidden from view, such as the famous pillars of creation in the Eagle Nebula. These discoveries have expanded scientific knowledge and sparked public interest in space. Originally designed for a 15-year mission, Hubble has far surpassed expectations, operating for over 30 years. Ongoing upgrades and refurbishments have kept it at the forefront of astronomical research, paving the way for future advancements like the James Webb Space Telescope. Throughout its mission, Hubble has conducted more than 1.5 million observations, contributing to thousands of scientific papers and solidifying its status as one of the most productive scientific instruments ever built. In addition to studying planets within our solar system, Hubble has provided critical insights into galaxies billions of light-years away, fundamentally altering humanity's perspective of the cosmos. One particularly fascinating discovery involves a nebula that resembles a human hand, often referred to as the Hand of God, captured by NASA's Chandra X-ray Observatory. This pulsar wind nebula, formed from a supernova explosion, contains a rapidly rotating pulsar known as PSRB 059-58 at its center. The powerful stream of particles emitted by the pulsar interacts with magnetic fields, creating the hand-like appearance. While it may seem to depict a recognizable shape, this phenomenon is an example of pareidolia, the psychological tendency to see familiar patterns in random designs. The Chandra X-ray Observatory has recently observed this structure at lower energy levels, and by combining data from both Chandra and Hubble, scientists have deepened their understanding of pulsar behavior. Mars, often called the Red Planet, has long fascinated researchers and space enthusiasts. Recent studies suggest that Mars once had a much more hospitable climate, potentially capable of supporting life. The planet's southern highlands, particularly near Hellas Planitia and the region of Hesperia, display valley networks resembling river systems on Earth. These formations imply the presence of flowing water around 3.5 to 4 billion years ago. Geological evidence indicates that Mars once possessed a much thicker atmosphere, allowing liquid water to exist on its surface. This revelation is particularly exciting for astrobiologists, as water is essential for life as we know it. Although the current Martian surface is inhospitable, with a thin atmosphere and frigid temperatures, ancient conditions may have been conducive to microbial life. Other factors, such as groundwater and melting glaciers, likely contributed to the formation of Mars' ancient water systems. To explore Mars' potential for past or present life, space agencies are planning future missions. The ExoMars mission, a collaboration between the European Space Agency and Roscosmos, aims to send a rover to Mars to search for signs of subsurface life. This mission will be complemented by the ExoMars Trace Gas Orbiter, which will study the Martian atmosphere from above. These missions are part of a broader strategy to extensively investigate Mars, with tentative plans that may include returning Martian samples to Earth for detailed analysis. Such an achievement would significantly advance our understanding of the planet's history and its potential for life. Studying Mars' watery past is not solely about understanding one planet. It offers valuable insights into planetary evolution and the conditions necessary for life to emerge and thrive. By comparing Mars' history with Earth's, researchers can better comprehend the factors that make a planet habitable and how these conditions change over time. Recently, NASA scientists made a historic discovery regarding Uranus, observing a polar cyclone at its north pole for the first time. This finding adds Uranus to the list of planets in our solar system with such atmospheric features, enhancing our understanding of planetary weather. The cyclone, characterized by a warm, dry core, was detected through the analysis of radio waves emitted by the planet, which are not visible through traditional optical observations. Unlike Earth's cyclones, which move across oceans, this cyclone remains stationary at Uranus' pole. The planet's tilted axis leads to extreme seasonal changes, making the observation of its poles particularly intriguing to researchers. Observations from the Very Large Array in New Mexico, conducted between 2015 and 2022, revealed that Uranus' north pole is hotter and drier than previously expected, suggesting the presence of a massive cyclone. This discovery challenges prior assumptions about Uranus' atmosphere and highlights the dynamic nature of gas giants. Comparisons with similar features observed on Saturn during NASA's Cassini mission provide valuable insights into the behavior of storms across different planets. One of the most captivating aspects of the cyclone is its stability, appearing to be a persistent feature, unlike storms on Earth that dissipate after landfall. The timing of this discovery is particularly fortunate, as Uranus' current orbital position allows telescopes to observe its poles clearly, providing researchers with a unique opportunity for in-depth study. This new knowledge enhances our understanding of planetary science and opens new avenues for future exploration. Further investigations may focus on the cyclone's internal structure, its interactions with Uranus' magnetic field, and its role in atmospheric circulation. We can anticipate more revelations that will not only enhance our understanding of distant galaxies but also provide insights into the diversity and complexity of planetary systems. Additionally, the discovery of semi-periodic pulses, resembling beats during solar flares, has transformed our understanding of solar storms. These signals, first identified in 2022, could hold the key to unraveling the Sun's mysterious heartbeat and offer critical insights into solar activity and its effects on space weather. By analyzing data from a medium C-class solar flare on July 13, 2017, a research team discovered two distinct pulsation patterns. The primary pulse occurred every 10 to 20 seconds and was traced to the current sheet space, where magnetic field lines break and reconnect during a solar flare. A secondary, softer pulse with a 30 to 60 second interval was observed throughout the entire current sheet. These findings challenge existing theories regarding the mechanisms of solar flare dynamics and energy release. The researcher suggests that both pulsation patterns likely arise from the formation of magnetic islands within the current sheet, where magnetic field lines bend and reconnect, playing a crucial role in energy release during solar flares. Understanding these pulsations is essential for predicting and mitigating the effects of solar storms on Earth. Solar flares and coronal mass ejections, CMEs, can disrupt satellite communications, affect power grids, and pose risks to astronauts. By decoding the Sun's pulse, scientists could develop better early warning systems for such events. The research team's findings also open new avenues for studying the Sun's magnetic behavior. Analyzing these pulses can provide insights into the complex processes occurring in the Sun's atmosphere during flares, which are difficult to observe due to intense heat and radiation. Furthermore, this discovery may have implications for understanding other stars. If similar pulses are detected in distant stars, it could provide significant information about their flare activity and magnetic properties. The study of semi-periodic pulses emphasizes the importance of long-term solar observation programs, as identifying and analyzing these subtle signals requires continuous, high-resolution monitoring of the Sun across various frequencies. As solar activity intensifies toward the peak of the current solar cycle, expected around 2025, these insights will be crucial for predicting and understanding solar weather events. The Sun's enigmatic pulses offer vital clues for unraveling the mysteries of its behavior and its impacts on our technological society. The galaxy known as M87 has expanded over time by absorbing smaller galaxies, which may explain its immense size and large number of globular clusters. Initially discovered by Charles Messier in 1781, M87 remains a focal point of ongoing research. With an apparent size of 9.6, it can be seen with a small telescope under ideal conditions, particularly in May. Recent observations from the Hubble Space Telescope have captured stunning visible and infrared images, revealing M87's spiral structure and the striking jet extending from its center. These new details provide astronomers with valuable insights into the formation and behavior of this colossal galaxy. Understanding M87 is crucial for deciphering how massive galaxies form and evolve, how supermassive black holes behave, and how galactic clusters operate. As observational instruments and techniques advance, M87 will continue to unveil new secrets about the universe and the extreme environment within it. NASA's InSight lander, launched in 2011, has been exploring Mars' Gale crater since 2012, providing valuable insights into the red planet's past. Under the leadership of project scientist Ushan Vasavada, the mission focuses on unraveling the mysteries of this specific Martian region, which formed about 3.5 billion years ago and offers a unique window into Mars' geological history. The primary question driving InSight's mission is whether this area could have supported microbial life in the distant past when Mars likely had a much thicker atmosphere and abundant liquid water, creating potentially favorable conditions for life. InSight's mission goes beyond searching for actual life forms. It aims to identify the fundamental requirements that could have made life possible. These include the presence of liquid water, carbon, and other essential chemical elements, as well as potential energy sources that primitive microorganisms might have utilized. In its inaugural year, the InSight lander made a pivotal discovery at Yellowknife Bay, revealing signs of an ancient lake bed that provided essential insights into Mars' historical climate. Chemical analyses indicated that the region was neither too acidic nor too salty, suggesting it may have been suitable for microbial life. Further investigations identified key life-supporting elements like carbon, nitrogen, sulfur, and phosphorus, along with potential energy sources that could have fueled microbial metabolism. Overall, these findings suggest that ancient Mars, particularly within the Gale crater region, may have had conditions conducive to supporting early life forms. The lander's ability to analyze the chemical composition of Martian rocks and soil has been instrumental in unraveling the planet's biological history. Kepler-186f, identified by NASA's Kepler Space Telescope, was the first Earth-sized exoplanet discovered within its star's habitable zone, located about 500 light-years away in the Cygnus constellation. Kepler-186f orbits an M-dwarf star, and its discovery marks a significant milestone in the search for potentially habitable planets beyond our solar system, as it resides in the star's habitable zone where liquid water may exist. Although its composition and mass remain uncertain, it raises hopes for finding more Earth-like planets. Titan, Saturn's largest moon, features a unique hydrological cycle with lakes and oceans of liquid methane and ethane. NASA's Cassini mission revealed that Titan's lakes vary in composition across its hemispheres and may have formed similarly to Earth's riverine lakes. These lakes experience seasonal fluctuations, indicating a methane-ethane cycle akin to Earth's water cycle. While Titan's lakes cannot support life as we know it, their complex chemistry presents opportunities for alternative life forms. Upcoming missions, such as NASA's Dragonfly set for 2026, will further explore Titan, potentially shedding light on planetary conditions and early Earth conditions for life. As the exploration of our solar system continues, established scientists are also keenly interested in the outer planets, particularly Jupiter and Saturn. These gas giants offer unique insights into planetary formation and atmospheric phenomena. Excellent example of the complex weather systems that can develop that has been raging for over 350 years. Recent observations from the Juno spacecraft have revealed detailed information about this storm's structure and the powerful winds surrounding it, enhancing our understanding of atmospheric phenomena not only on Jupiter but also on exoplanets with similar characteristics. Saturn, renowned for its stunning ring system, is another focus of interest. The Cassini-Huygens mission, which concluded in 2017, provided a wealth of data about the planet's moons, including Titan and Enceladus. Titan's thick atmosphere and liquid methane lakes create an environment that may harbor life forms with biochemistry vastly different from what we know. In contrast, Enceladus has demonstrated geysers that eject water vapor and organic compounds, suggesting the presence of a subsurface ocean beneath its icy crust. These discoveries make both moons ideal targets for future missions aimed at understanding the potential for life beyond Earth. The search for extraterrestrial intelligence, SETI, has also gained momentum in recent years, with various initiatives focusing on detecting signals from distant civilizations using advanced radio telescopes and algorithms to analyze vast amounts of data. The discovery of potentially habitable exoplanets has heightened interest in these searches.